Let's take a look at this example. We have the limit of the radical. You can rewrite this problem as simply square root of limit with x is going to negative infinity and simply 18x to the fifth minus 4 over 2x to the fifth minus x to the third. Next, we're supposed to divide every single term in the fraction by the variable with the highest exponent in the denominator. So I'm going to have simply square root, and this is going to be limit x is approaching to negative infinity, and I'm going to have 18x to the fifth over x to the fifth minus 4 over x to the fifth over 2x to the fifth over x to the fifth minus x to the third over x to the fifth equals x to the fifth and x to the fifth will cancel out. And let's take a look what we are going to have right now. We have simply limit x is approaching negative infinity, and of course we have square root, and we have 18 minus 4 over x to the fifth over 2 minus 1 over x to the second power. Let's take a look at these two fractions. In the numerators, we have constants. If x is going to negative infinity or positive infinity, this fraction is going to approach 0. The same story happens over here. Again, I have constant, and if x going to negative or positive infinity, this fraction is going to approach 0. That's why I have nothing else, just simply 18 square root of 18 over 2. So this is nothing else, just square root of 9, and square root of 9 is equal 3. This is the solution to my problem. We have another example. I would start solving this problem from factoring the numerator. You can rewrite this as limit with x going to negative infinity, and I'm going to factorize x squared from the numerator. So I'm going to have x squared, and inside of the parentheses I'm going to have 1 plus 1 over x, close parentheses, and I'm going to copy down the denominator. I have 5x plus 2. Next, I'm going to rewrite limit x goes to negative infinity, and I'm going to rewrite this radical as a product of two radicals. So I have square root of x squared times square root of 1 plus 1 over x over 5x plus 2. Next, I'm going to apply the rule for the square root of x squared. This is equal absolute value of x. So instead of square root of x squared, I'm going to simply write limit x is going to negative infinity, and I'm going to write absolute value of x times square root of 1 plus 1 over x over, and because I have x over here, I'm going to also factorize x from the denominator in order to cancel out this x and the one which I'm going to create in the denominator. So I have x, and inside of the parentheses I'm going to have 5 plus 2 over x. Next, look at the absolute value of x. We're supposed to use the definition. Because my x is approaching negative infinity, means the x values are going to be less than 0. So instead of absolute value of x, I'm supposed to write negative x. And I'm going to have limit x is approaching to negative infinity, and instead of absolute value of x, I'm going to write negative x times 1 plus 1 over x over x, and I have 5 plus 2 over x. X and x will cancel out. If x is approaching negative infinity, so this fraction is going to approach 0. And this fraction is going to also approach 0. That's why I'm going to have square root of 1 over 5. Of course, negative. Square root of 1 is 1. I'm going to have negative 1 over 5. And this is the solution to my problem.